Salam and peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Episode 6, Part 6. Imagine you are standing in front of a huge wall. On this wall, every book ever written is pinned side by side. Every equation, every poem, every physics paper, every religious text, every love letter, every software program. All of human culture, all of science, all our attempts to describe the world, pressed together like a single vast mosaic of ink and symbols. Now imagine someone walks up to you and says, all of this, every single page, was secretly written in one single alphabet. Not 26 letters, not thousands of characters. One symbol, one shape, one kind of mark, twisted and combined in many ways. At first, that sounds impossible. How can one symbol contain enough variety to describe everything? But if you think more deeply, you realize we already do something like this. A computer, for example, uses just two symbols, 0 and 1. From that tiny alphabet, we build photos, movies, books, music, simulations, whole virtual worlds. A single piano key, struck again and again at different times and strengths, can build a rhythm, then a song, then a whole symphony. A single brushstroke, layered and rotated and repeated, can make a painting. The idea at the heart of the holophase is even more radical. It says, what if reality itself is like that? What if everything you see and feel, time passing, space stretching, your body moving, light shining, atoms binding, is not made of many different ingredients, but is all different ways of reading one underlying field? Not a field of matter, not a field of energy, a field of phase, a kind of cosmic angle, a rhythm defined everywhere. We call it the holophase, and we write it with a simple symbol, phi. In this episode, we are not just going to talk about phi as an idea. We are going to treat it as a language, the language of reality itself. And our goal is ambitious but simple. By the end of episode 6, you should be able to think in this language. You should be able to look at the world around you and say, quietly inside your mind, this is not just space and time and motion. This is phi speaking. This is the holophase field, expressing itself through its patterns and its changes. To understand why we even dare to talk about the language of reality, we have to step back for a moment and look at how physics has evolved. For most of history, humans thought in terms of things: rocks, fire, water, air, gods, souls, objects with names and boundaries. Then we refined this into smaller things, atoms, then into smaller things again, electrons, protons, neutrons, then into an even stranger zoo, quarks, gluons, leptons, bosons, Higgs fields. We build beautiful theories that describe how these things interact and how they transform into one another. But if you step back and look honestly, it can feel messy, like a dictionary with too many root words. Like a language where each sentence is built from a completely new alphabet. Every time we probe deeper, we found more variety, more particles, more exotic fields. It works incredibly well for predicting experiments, but it does not feel like a single clear story. It does not feel like one coherent language. The holophase perspective is a different kind of move. It does not add another particle to the zoo. It says instead, maybe the zoo itself is a shadow of a simpler reality. Maybe there is one continuous field, phi, that lives everywhere in the universe, at every point in space and time. And everything we call particle, field, force, space, time, even motion, is just a different way of looking at how this phi changes. This is where the idea of a language becomes powerful. A language is not just a list of symbols. It has an alphabet, the basic shapes or sounds. It has a grammar, rules for combining them. And it has semantics, a way those combinations mean something. For human language, the alphabet might be letters like A, B, C, or sounds like ka, s. The grammar tells us how to build words and sentences. The semantics tells us that I am here is not just a pattern of sounds, it has meaning. In the holophase view, the alphabet is not made of particles. It is made of the ways phi can change. The most basic letters are the derivatives of phi, how phi changes in time, how it changes in space, and how those changes themselves change. The grammar is the set of relationships between these derivatives, how time change and space change join to make motion, waves, forces, and so on. And the meaning is the physical world itself, light and matter, the way things move, the way patterns persist and interact. In other words, physics becomes a kind of phase linguistics, the study of how reality writes itself in terms of phi and its derivatives. This might sound abstract, so let us ground it in a very simple picture. Imagine you are walking on a hill. At any point on the hill, you can ask three kinds of questions. First, what is my height right here? Second, how steep is it here and in which direction is it steepest? Third, how is the steepness itself changing as I move? The first question gives you a simple number, the height. The second gives you a direction and a slope, how quickly the height is changing. The third gives you curvature, how the slope bends and twists. In mathematics, the height is like a field, something defined at every point. The slope is the first derivative of that field. The curvature is the second derivative. If you kept going to higher and higher questions, how the curvature changes, how the rate of change of curvature changes, you would build a tower of derivatives. Here is the crucial point. If you know the height and all its derivatives at a single point, you can, in principle, reconstruct the shape of the hill around that point. You do not need a separate object for slope, another for curvature, another for twist. They are all different aspects of the same underlying thing, the height function. The holophase says, think of reality like that hill. Phi is like the height. Its derivatives are like the slopes, curves, and twists of the phase landscape. Everything we call time, space, motion, field, particle becomes a way of reading these derivatives. Later in this episode, we will learn that the way phi changes in time at a point defines something we call omega, the local rate of ticking, the temporal echo of phi. The way phi changes in space at a point defines something we call k, the local pattern of twisting, the spatial echo of phi. By combining these, we can define a velocity, v, that tells us how patterns in phi move. This is the motion echo of phi. So time, space, and motion are not separate ingredients. They are three simultaneous echoes of the same song. There are three ways of reading how phi changes. Let us use a musical analogy, because the universe in this picture is deeply musical. Suppose you are listening to a violin sustain a single note. If you freeze time and look at the vibrating string, at each point along the string there is some displacement, up or down. That displacement is like phi. But you do not experience just the displacement. You experience the tempo, how quickly the note is being played, how fast the vibrations repeat. You experience the pitch, how tightly those vibrations are packed. You experience the timbre, the rich structure of overtones and hidden harmonics. Those features are not extra objects separate from the string. They are different derivatives and combinations of derivatives of the string's motion. The holophase says, reality is like that violin string, but everywhere, in all directions, all at once. Phi is the underlying oscillation. Its time derivatives give you the local tempo, how fast the phase is turning. Its space derivatives give you the local spatial wavelength, how quickly the phase twists as you move. Higher derivatives give you the richness, the texture, the accent of the cosmic note. When we call this a language, we mean that the universe is not writing equations in chalk on a blackboard. It is writing phase patterns in itself. Every change is a syllable. Every stable structure is a sentence. Every law of physics is a grammar rule about which patterns are allowed and how they evolve. Why do we need this language viewpoint at all? One answer is practical. We want a unified way to talk about everything. Not one framework for particles, another for fields, another for spacetime, another for information. We want a language that does not break when you move from quantum to cosmic scales. A language that does not care whether you are talking about light, gravity, fluids, or brains. But there is a deeper answer. When you think in terms of things, particles, objects, substances, you are always tempted to ask, what is this thing made of? What is under this? What is beneath the beneath? When you think in terms of a language, the question changes. You stop asking, what is this made of? And start asking, what pattern is this an example of? What sentence is being spoken here? Which grammar rules hold this structure together? A single paragraph in a book may contain a hero, a villain, a war, a love story. But all of those characters and events are made of the same letters, arranged in particular patterns. You do not ask, what is the hero made of, in a physical sense. You ask, how is this character written? What role do they play in the story? What pattern do they obey? The holophase invites you to see electrons, stars, waves, even your own thoughts in the same way. Not as separate substances, but as recurring patterns in Phi's language. Some patterns are stable and local, like defects, knots in the phase. Some are extended and wave-like, like light. Some are complex and nested, like brains and societies. At the base, they are all written with the same pen, Phi and its derivatives. Another analogy can help. Think of a woven carpet, like a Persian rug. At first glance, you see shapes, flowers, animals, geometric borders. You might even give them names, the bird motif, the tree of life, the central medallion. If you look closer, all of those shapes are made of one kind of thread, looping in and out, crossing over and under. The pattern on the surface is a projection of a deeper, more fundamental process, the sequence of knots and crossings made during weaving. In this analogy, the thread is Phi. The way the thread passes from one knot to the next, the little local moves, is like the local derivatives of Phi. The large-scale pattern on the rug is like the physical world, the galaxies, atoms, fields, bodies. A knot in the thread that cannot be undone without cutting is like a topological defect in Phi, something we will later see as a particle. You could try to describe the rug in terms of objects, birds, flowers, diamonds. Or you can describe it more fundamentally, a single thread woven according to particular rules, whose crossings generate those shapes. Physics up to now has been mostly in the object mode, listing the bird, the flower, the symbols. The holophase perspective moves to the thread and weaving mode. It asks, what if the universe is one infinite rug being woven in real time? What if Phi is the single thread? What if every knot and pattern is a phase configuration? And what if the only thing you truly need to study to understand all of it is the grammar of weaving, the rules governing Phi and its derivatives? Now we come to the heart of this first part. Why a language of reality? Because nothing else is simple enough, and nothing else is rich enough. If you say the universe is made of particles, you still need rules for how they move in time, rules for how they interact in space, explanations for why their properties are quantized, why they are stable, why they have certain masses and charges. If you say the universe is made of fields, you still need a way to tie those fields together, a way to explain the topological structures, the defects, the emergent particles, a way to unify space, time, and motion into one consistent picture. A language perspective forces you to think in terms of one substrate, phi, the holophase field, one set of operations, derivatives with respect to time, space, and combinations of both, one atlas, the structured catalog of all these derivatives, from first order up to arbitrarily high order, one grammar, constraints and relations among these derivatives, which we experience as physical laws, and many stories, every physical phenomenon as a sentence spoken in this language. You might ask whether this just pushes the mystery down one level. Instead of what are particles, you now ask what is phi. In a way, yes, but now the question is better posed. Phi is not a particular object. It is a mode of being. It is a way the universe exists, as a continuous, cyclic phase defined everywhere. You do not have to imagine tiny beads or bricks. You imagine relationships, how much ahead or behind one region of the universe is compared to another in this cyclic rotation of the phase. From those differences, those phase offsets, you can build everything. Just like music is not about the absolute pitch of one note, but about intervals, the universe, in this view, is not about absolute phase, but about phase relationships. And those relationships are exactly what derivatives measure. There is one more ingredient we must plant in your mind before we move on. When you hear the word derivative, you might remember school, where it was introduced as a dry tool for calculus, something about slopes of graphs. Here, we will treat derivatives differently. We will treat them as letters of a cosmic alphabet. Each derivative answers a specific kind of question. How is phi changing as time flows? That gives us a time letter. How is phi changing as we move through space? That gives us a space letter. How is the pattern of change itself changing? That gives us higher order letters. Put all of this together and you get a tree of derivatives growing out of phi, like branches from a single trunk. This tree is infinite in principle. You can keep differentiating as many times as you like. But, just as in human language, many possible sentences will never be spoken, and many possible words will never be used. In practice, the universe seems to speak in relatively low orders most of the time. Most of physics can be understood with just the first 2 or 3 levels of this tree. Throughout this episode, we will come back again and again to this picture. A single phase, phi, at the root, a branching tree of derivatives above it, at each level more detailed, more nuanced descriptions of how phi behaves, and from these patterns of behavior, everything else emerges. Time, space, and motion will not appear as separate stage elements. They will appear as different readings of the same derivative structure. Before we close this part, let us slow down even more and walk through a few everyday scenes and quietly translate them into the beginnings of holophase language. Imagine you are sitting at a train station, watching a train glide past the platform. In the usual way of speaking, you might say, "The train is moving through space as time passes." You imagine space as a kind of empty container, time as a flowing river, and the train as a solid object sliding through both. In holophase language, you tell a different story. You imagine that at every point in the region around the train, phi is defined. It has a value there, an angle on that cosmic circle. As the train passes, phi in that region changes in a particular pattern. The time derivative of phi, the local omega, is different near the train than far away. The spatial derivative, the local k, has a different structure around the shape of the carriages and the tracks. The motion of the train is not something extra, riding on top of phi. It is the pattern of how phi's derivatives arrange themselves in that region. What you call the train is a stable repeating sentence in the language of phi. You can do the same exercise with something as simple as a swinging pendulum. In ordinary physics, we say the bob moves back and forth, slowed a little by air resistance and friction. In holophase language, we say there is a region of the universe in which phi is cycling with a very particular rhythm. The time derivative omega is higher near the bottom of the swing, lower near the turning points. The spatial derivatives k change as the bob moves through different positions. The fact that the pendulum returns again and again to the same places is not a mystery. It is the signature of a sentence that loops, a piece of grammatical structure in phi that is closed on itself. Even something as intimate as your own heartbeat can be reread like this. When your heart contracts, there is a wave of electrical activity passing through your cardiac tissue. That activity is usually described as voltages and ion flows. In holophase language, those voltages and flows are manifestations of phase relationships in the tissues, tightly coordinated patterns in phi and its derivatives. The beat you feel in your chest is the echo of a deeper, continuous oscillation written in the holophase field. As you practice these translations, you begin to feel a shift. Instead of seeing the world as a collection of separate lumps, your mind starts to see it as a single, continuous fabric of change. You notice rhythms and patterns everywhere. You notice that the important questions are not, what is this object made of? But, what structure is being played here? What phase pattern is being written? Another way to appreciate the need for a language view is to think about how different scales of reality talk to each other. At the smallest scales, we have quantum fields and particles. At human scales, we have fluids, solids, organisms, societies. At cosmic scales, we have galaxies, clusters, filaments of dark matter. Traditionally, we use different mathematical tools for each level. Quantum field theory here, fluid dynamics there, general relativity somewhere else. They work beautifully in their domains, but they do not always speak to each other clearly. It is like having one language for chemistry, another for weather, another for galaxies, with only rough translation between them. The holophase aims to give us a single underlying language beneath all of these. The idea is not that every equation in physics suddenly becomes trivial, or that all problems disappear. The idea is that at the deepest level, they are all phrases in the same language, expressions of phi and its derivatives obeying certain constraints. The same fundamental alphabet writes atoms, storms, brains, and black holes. What changes from one domain to another is not the alphabet itself, but which words are common, which grammar rules dominate, which patterns are stable. This is like the way the same human language can write a children's story, a legal contract, and a poem. The alphabet is the same, the grammar is the same, but the style, the rhythm, the kind of sentences we use are different. In the same way, the holophase language can express quantum experiments and galaxy formation with the same basic letters, while the accent and vocabulary change with the scale. There is also a philosophical reason why the language picture matters. If you imagine reality as made of things in a container called space-time, you are always one step removed from the actual experience of being alive. You, as a subject, stand here and look at objects over there. You imagine a gap between you and the world. The holophase picture is more intimate. It says you are not outside the language observing it from the shore. You are made of the same phase field. Your thoughts, your feelings, your sense of flow and change are themselves written in phi. When you understand holophase language, the universe is not something you stand apart from and decode. It is something you are woven into, a story you are made of. This does not mean the theory becomes mystical or vague. Quite the opposite. Treating phi as a language forces us to be more precise. Every symbol must be explained. Every derivative must be given a clear meaning. The hierarchy of letters must be laid out in an orderly way. The atlas of derivatives must be complete and free of contradictions. That is the work we are going to do in this episode. Picture again the tree at night, lit from below. You see the thick trunk rising from the ground, then large branches, then finer branches, then twigs, finally disappearing into darkness. The trunk is phi itself, the raw phase field. The first big branches are the first derivatives, the temporal echo omega and the spatial echo k. The thinner branches are second derivatives and mixed derivatives, how omega and k change, how curvature appears, how patterns bend and twist. The finest twigs are the very high-order derivatives that almost never matter in everyday life, but are still part of the full structure. Somewhere among those branches, in special knot-like arrangements, live the stable defects that appear to us as particles and charges. Most of the time, when we do physics, we work on just a few branches of this tree. We look at low-order derivatives, because they already tell us an enormous amount. But the whole tree is always there in the background, rooted in phi. The language of reality is this tree. The atlas of the holophase is its precise mathematical description. In episode 6, part 6, our task is to stand with you at the base of that tree and look up. We are not yet climbing the branches in detail. We are letting your eyes adjust to the shape. We want you to feel that a single living structure, rooted in one simple concept, can produce all the variety you see in the universe. As we move into the next parts, we will start to climb. We will take the first steps up the trunk into the low branches, meeting phi more closely, then omega and k, then the unified differential dphi, then the derived motions and flows. We will see how time, space, and motion arise not as separate axes, but as three simultaneous ways of moving through this tree. Three coordinated readings of the same derivative structure. As you listen to the rest of this episode, you do not need to hold all of these images perfectly in your mind. It is enough to remember a few anchors. The huge wall of human knowledge, secretly unified by one deeper alphabet. The hill whose slopes and curvatures echo the way derivatives reveal structure. The violin string whose single vibration becomes tempo, pitch, and timbre. The woven rug whose many figures are all drawn by a single thread. Each of these is a doorway into the same insight. There is one field, phi. Its changes are the letters. Its relationships are the grammar. The world you live in is the story that grammar allows to unfold. With that in place, we are ready to begin walking slowly, step by step, into the actual alphabet of reality.